For problem 5.31, we know that the early voltage is 20 volts, and we in this early voltage is the same for ID equals to 1 milliampere and 0.1 milliampere. Okay, so in part A we need to find out what's the value of the output resistance, right? So first we need to calculate the channel modulation parameter, which is lambda, that is equals to 1 over the early voltage. And in our case, because the early voltage is the same for both conditions, is just 1 divided by 20 volts, that is 0.05 reciprocal voltage. So that's that's lambda. Now to calculate the output resistance R naught 1, we know that it's 1 over the channel modulation parameter times the current ID1. And that's the same for the second resistance. So it's 1 over lambda times ID2. In our case, ID1 is 0.1 milliamps and ID2 is 1 milliamp. So if we substitute lambda here, here, and here, and the current, we get the first resistance as 200 kilo ohms and the second resistance as 20k ohm. Now for part B, we are changing VDS by 1 volt, and we want to find out what's the change, the percentage change in the drain current. So there's one equation that we can write, that ID plus a change in ID is equals to ID times 1 plus lambda change in VDS. Okay, so we know our ID1, it would be this ID1 here, and then the change in ID would be proportional to ID times this change in VDS, right? So if we isolate the terms here, so this ID here will cancel with this ID here, and then we are left with the change in ID equals to ID times lambda, the channel modulation parameter, times the change in VDS. So if we want to find out this percentage here, it's basically the ratio between the change in ID divided by ID, right? The change divided by the value of ID, that gives us the percentage. That's equals to lambda times delta VDS. And in our case, because lambda is the same on both conditions, right? The early voltage is the same. This delta ID divided by ID, and we can multiply by 100 to get a percentage. It's equals to 0.05 times 1, that's the change in VDS. And because I multiply by 100 here, I'll multiply by 100 on the right hand side too. And this gives us a delta ID percentage that's equals to 5%. And notice that this change in ID, it is the same for both currents. So for the first current, so delta ID percentage 1, this corresponds to roughly, let me see here, to 5 microamperes. And for the second current, ID over ID percentage 2, that corresponds to 50 microamps. But the percentage is the same. Now the absolute value, it changes because the magnitude of the currents, they are different.